Yes, good morning, dear students. Welcome to our physics class. So, today we are going to study about motion of plane with a constant acceleration. Motion of plane with a constant acceleration. That is constant acceleration. So here we need to consider an object which is moving in a plane with constant acceleration. Okay? If the motion is in a constant acceleration, then we can say the average velocity in any interval of the time will be equal to that constant acceleration. Okay, throughout the motion, the acceleration is not going to vary; it will remain constant, right? So here we consider initial and the final velocities, because if we have different velocities, then only we can come across the acceleration. So here we need to consider one initial velocity, that is we'll consider as a u, and the final velocity, that is considered as a v. Okay, so here consider a particle moving in a plane with constant acceleration. Okay. So here, let us consider u be the initial velocity at time t is equal to 0. Then v be the final velocity at time t is equal to t, right? Then acceleration vector, we can write it as acceleration is nothing but a rate of change of velocity with respect to time. So here final velocity minus initial velocity vector divided by the interval t minus 0, which is nothing but v minus u divided by t. Is it clear? So which implies, so v as it is, you just have to bring this t to this side, then it will be equal to a into t, and then you have to bring this minus u to the opposite side or LHS side, then it will become u plus ad, right? Okay. Now, if you simply have dropped this equation as it is, then that will be a motion in a straight line case. But here we are dealing with a motion in a plane. So here the motion corresponds to both x and y axis. So that's why whatever velocity we are having and whatever acceleration we are having, those will be corresponds to both x and y axis. So now we have to resolve here the velocity vector as well as the acceleration vector into two components, that is, one is along x-axis and another one is along y-axis. So let me do that one. So here velocity, the component of velocity along x-axis, I take it as vx I cap plus the component of velocity along y-axis, that is v by j cap, which is equal to ux I cap. Instead of u, I'll consider its component along x and y axis, that is ux I cap plus uy j cap. Okay, and plus again here acceleration is a vector. I need to consider its component along x and y axis respectively. So that is ax I cap plus ay j cap into t. make all the coefficients of I in one side and all the coefficients of j in one side. So that implies Vx I cap plus Vy j cap, which is equal to, so here we are having the ux of the coefficient of I cap, and here ax into t is the coefficient of I cap. So I will bring them under one bracket. So that is ux plus ax into t I cap, right, plus uy plus ay into t into j cap. I hope you understand, right? I just brought all the terms which are coefficient of I under one bracket and the terms which are coefficient of j cap under one bracket. That's it. Okay. So here in this equation we can say, we just have to compare the coefficients of I from LHS and RHS and also the coefficients of J from LHS and RHS. As we can compare the coefficients of I from LHS and RHS, we can write here. So here Vx is equal to, so here Vx is the coefficient of I cap. Okay? Then here it is equal to ux plus ax into p. So what we can write here? So Vx is nothing but the component of a velocity vector along x-axis. Okay? Component of the velocity vector v along x-axis. Right? Similarly, compare the coefficients of j from LHS and RHS. You can get Vy is equal to uy plus ay into t. So now it is the component of velocity vector along y-axis. Is it clear? Okay. So next, we need to move for position vectors. Okay. So now let us consider R1, vector R1 as a position vector at time t is equal to 0. At t is equal to 0. Right? Similarly, R2 vector is position vector at time t is equal to t. Right? Then here, the displacement during the interval t is equal to 0 to t is equal to t. So that interval means t minus 0 is equal to t. So during the interval t is, we consider delta r. We consider it as a delta r. Delta r is the displacement, or we can consider it as a displacement vector during the interval t. Okay? As we have studied in previous derivations, the displacement vector will be equal to r2 minus r1, the difference between the position vectors of a final and initial time. Right? So that is the displacement vector. Right? Now, the average velocity of a particle during the interval t is given by average velocity of particle during interval t is, we can write here, we are having two velocities, one is the initial, that is u, and another one is the v, that is the final. The average of these two velocities will be u plus v divided by 2. So it is the average velocity during the interval t. Then how can we write the displacement vector during the interval t? So that is displacement vector during t is given by, as we can say, displacement is equal to velocity into time. V is equal to, velocity is equal to displacement divided by time, right? Then displacement is equal to velocity into time. So here the displacement vector, that is delta r, which is equal to a velocity which we have here, the average velocity during the interval. So that is vector u plus vector v divided by 2 into the time, that is t. Is it clear? And here also I write the vector notation, right? Okay. So now just have to substitute the value of v from this equation. That is delta r is equal to u plus, instead of v, we need to write u plus at divided by 2 into t. Okay? So here we are having the two u's. So that implies delta r, which is equal to 2u, okay, plus 8 into t, u plus 2u plus 8 into t, and again I bring this t inside, then it will be multiplied with the 2u, that is 2ut, and here it is space, divided by 2. So I will just make a fractionalization. That is divided by 2 divided by 2. So cancel 2 on denominator and numerator at the first term. So then that implies delta r is equal to ut plus half at square. Right? Delta r is equal to ut plus half at square. Okay, so this is for motion in one dimension. Delta r means that is the displacement vector. So it is just like a s is equal to ut plus half at square. But that is for a motion in a one dimension or a motion along the straight line. But here we are dealing with the motion of plane. Okay, so just we need to proceed further. For that one, so just write vector notation here. So if you are dealing with the motion of plane, we need to write the vector notation compulsory. Okay, because it includes direction. Right. Then here, where delta r is equal to, as we have derived in the previous derivation, that is delta x I cap plus delta y j cap. Then a velocity vector u is equal to ux I cap plus uy j cap. Okay. Then acceleration vector ax I cap plus ay j cap. Clear? Okay, now just you have to substitute these values in this equation. Right? These values in this equation. Let me write this. Instead of delta r, what I need to write? Delta x I cap plus delta y j cap. Therefore, delta x I cap plus delta y j cap, which is equal to u. So u, what I need to write? This one. Ux I cap plus uy j cap. Okay, instead of u. And then t. Okay, plus half. Instead of A, I need to write AX I cap plus AY J cap, okay, and into T square, right? So now I need to write the all coefficients of unit vector I under one bracket and all the coefficients of unit vector j under one bracket. Okay. So now I'll just rearrange the terms here, right? Okay, there is no space. So that implies delta x I cap plus delta y j cap, which is equal to, look here, ux into t, ux into t first, right? These will come as the coefficients of vector I cap, and then in this term half into ax into t square. They're going to come as a coefficient of I cap. So I'll just write them under one bracket. So that is ux into t plus half ax into t square. T square. Okay. So then into I cap. Into I cap. Similarly, I need to write all the coefficients of j cap under one bracket. So that is, look here, uy into t plus half ay into t square. So here plus uy into t, okay, uy into t, and then here plus half ay into t square, j cap, right? I just rearrange the terms now to get the coefficients of I cap under one bracket and the coefficients of j cap under one bracket. I just rearrange the terms, right? So still we have this expression or derivation. You just take a screenshot of all the things whichever have written on the board. Okay. Just take that screenshot now. Okay. Next, the continuation part of this expression here. You just have to compare the coefficients of I, vector I cap from both LHS and RHS. You just have to compare the coefficients of I and j from LHS and RHS. In the LHS side, coefficient of I cap is nothing but delta x, right? So here delta x, which is equal to the coefficients of I cap and RHS where dxt plus half ax t square. So ux into t plus half ax into t square, right? And here delta y is equal to the coefficient of j from both LHS and RHS side. We have delta y at the LHS, and at the RHS we are going to have uy into t plus half ay into t square. And then what these two factors are going to denote or going to represent? So that is the displacement along x-axis and displacement along y-axis. I hope you understand. Okay. So here for this expression, so we have a result of acceleration along x and y direction, right? And velocity along the x and y direction. Now finally the displacement along x and y direction. Is it clear? So that equation there, delta x is equal to is nothing but the displacement displacement along x-axis. Okay, and here delta y is displacement along y-axis. Right? So just write these things in your notes. Okay. Okay, the next concept is the projectile motion. Projectile motion. Projectile motion. What do you mean by the projectile motion? If any object is thrown in the space, with certain initial velocity, which is making an angle with the horizontal, and that is called as a projectile motion. Just see here. So it is the ground. Just imagine this is the ground, and a player who is standing here, who is playing the cricket. Okay. So now he will throw a ball from this place like this. Okay. He will throw a ball from this place with a certain velocity in this direction, right? So then, how does this ball will go in the space, or what type of path it will trace after throwing it in a space, right? So it will travel like this. Okay. It will travel like this. And this sort of motion is called as the projectile motion. This is called as projectile motion. So here the player will throw the ball with certain initial velocity, and the direction of velocity is this one. Okay. And here this initial velocity will make an angle theta with the horizontal. So this case of motion is called as a projectile motion. If you throw the ball, so it will travel like this. Okay? It will travel with certain initial velocity, and when it is traveling, it will make an angle with the horizontal. So this case of motion is called as projectile motion. Okay? An object thrown in space. Object thrown in a space with certain initial velocity, okay, making an angle with horizontal. Is called as projectile motion. It's called as projectile motion. Okay. The next one is the velocity of projection. The velocity of projection. So the velocity with which the object is projected is called as velocity of projection. Okay. The object which is thrown with certain velocity, initial velocity, right? And that velocity is called as the velocity of projection. Velocity of projection. The velocity with which the object the object is projected or is thrown. Okay, it's called as velocity of projection. Velocity of projection. Okay. The next one is angle of projection. Angle of projection. So here the angle made between the path of the projection and the horizontal, or the direction of projection and horizontal, is called as angle of projection. The angle made between the direction of projection and the horizontal is called as angle of projection. Okay. And next comes the trajectory of a projectile. The trajectory. What do you mean by the trajectory? It is nothing but the path traced by the projectile. The body which is performing the projectile motion, so whatever path traced by that body is called as trajectory. The path of the projectile is called as trajectory. The path traced by the projectile. The path traced by the projectile is called as trajectory. Okay. Take a screenshot and write these all in your notes.